Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P16F3, indicates a low voltage issue in the starter cut relay 1 control circuit. This issue is specifically identified when the powertrain control module, PCM, detects a low return signal from the starter cut relay when the engine is off. Understanding how this relay operates is essential. It is responsible for enabling the starter motor to crank the engine. Located in the relay circuit board, starter cut relay 1 circuit connects to several components along the starting system pathway. When the relay fails to provide the appropriate signal or voltage, it causes the PCM to store this code, flagging a malfunction. Therefore, thorough troubleshooting is vital to identify and rectify the root cause of this low voltage condition. DTC P16F3 specifically points to a malfunction in the starter cut relay 1 control circuit, affecting the vehicle's ability to start. This relay is part of the relay circuit board, situated within the engine compartment. Its primary role is to manage the power supply to the starter motor by receiving a signal from the PCM. When the starter is turned off, the PCM monitors the return signal from the relay. If this signal is indicated as low, it judges there to be an abnormality, storing the DTC for further analysis. Understanding the relationship between these components, the relay, the PCM, and the overall starting system, is crucial in diagnosing this issue effectively. Several potential causes can lead to the activation of DTC P16F3, each of which needs thorough investigation. One probable cause could be insufficient voltage in the relay circuit, which may stem from a weak battery or corrosion in connections. Another possibility is a malfunctioning powertrain control module, PCM, that does not correctly interpret the electrical signals from the starter cut relay. Additionally, open or short circuits in the wiring can lead to improper signals being sent or received, further complicating the diagnosis. Identifying these causes will help technicians focus their efforts on the most likely sources of the problem, ensuring a more efficient troubleshooting process. The symptoms associated with DTC P16F3 can manifest primarily as the engine failing to start. When the starter cut relay is not functioning correctly, the engine may not crank over at all, as it does not receive the necessary signal. Additionally, one may observe warning lights illuminated on the dashboard as the vehicle's control systems detect the malfunction. In some cases, the vehicle may exhibit unusual electrical behavior, such as flickering lights or intermittent electronic issues, indicating a broader electrical problem. Properly identifying these symptoms can guide the technician in narrowing down the cause of the malfunction. The first step in troubleshooting DTC P16F3 is to turn the vehicle to the on position without starting the engine. This allows access to the vehicle's electrical components while the engine is inactive. Confirming the engine start conditions is crucial. Verifying whether the vehicle cranks when the ignition is activated can provide immediate insights into the issue at hand. If the vehicle starts successfully, it indicates that the low voltage issue may be intermittent or related to a specific condition. The next steps depend on the results of this initial check, guiding future troubleshooting processes. Following the initial inspection, the next step involves checking the external circuit related to the starter cut relay 1. This includes inspecting the IG1 ACG and stack cut relay 1 CL circuits, which are essential for powering the starter system. Using appropriate diagnostic tools, ensure that power flows through these circuits correctly when the vehicle is in the on mode. Detectors must assess circuit integrity, confirming that no opens or shorts are affecting the relay's performance. These measurements will yield valuable information concerning the relay's operational state and the overall health of the circuit. In the third step, it is imperative to conduct thorough wire inspections to identify any shorts or open circuits within the starter cut relay 1 control circuit. This involves checking the wiring and connectors associated with relay circuit board and the PCM. Using a multimeter, measure the resistance in the circuit. A reading of less than 1 ohm indicates there is a direct path between components, while a reading over 1 megohm signifies insulation is intact, and the circuit is not grounded. If an abnormality is detected, focus troubleshooting efforts on the affected wiring, as this may reveal the cause of the low voltage issue that triggered DTC P16F3. After verifying external circuits and wiring integrity, the next step is to test the functionality of the Powertrain Control Module, PCM. The PCM is a crucial component as it processes signals from various sensors and relays within the vehicle. Ensuring that the PCM is correctly interpreting these signals is vital for the starter system's operation. Use diagnostic tools to examine the inputs and outputs of the PCM, checking for any abnormal readings that could point to a malfunction. If the PCM shows signs of failure or abnormal behavior, replacement may be necessary, directly impacting the resolution of DTC P16F3. Once all potential issues have been addressed, including wiring and PCM functionality, it is essential to verify that repairs are successful. Start by clearing the diagnostic trouble code, DTC P16F3, from the system using a diagnostic tool. After clearing the code, retest the vehicle by attempting to start the engine. Ensure that all connections and repairs are secure, mitigating the likelihood of recurring issues. If successful, there should not be any alert codes. Confirming that the starter cut relay control circuit is functioning within specifications. Thorough verification is a critical step in ensuring the long-term reliability of the vehicle's electrical and starting systems. Preventive maintenance is crucial in avoiding issues like DTC P16F3 in the future. Regular electrical inspections can catch potential problems before they escalate into significant failures. It is advisable to check battery condition periodically, as well as clean terminals to prevent corrosion that can inhibit electrical flow. Additionally, ensure that connections related to the starter cut relay and PCM are intact and free from wear or damage. Educating vehicle owners on the importance of scheduled maintenance can significantly reduce the risk of electrical issues arising, ensuring a reliable starting system at all times. In summary, addressing DTC P16F3 involves understanding the components involved, such as the starter cut relay 1 and the PCM, and following a systematic troubleshooting process to accurately diagnose the issue. Recognizing the electrical pathways and potential failure points is essential for effective repair. Following the recommended steps will not only aid in resolving low voltage concerns, but also enhance the vehicle's performance overall. Moreover, implementing regular maintenance practices can prevent the recurrence of such issues in the future, ensuring optimal functionality of the vehicle's electrical systems. By being proactive, technicians can maintain the reliability of Honda CR-V 2023 Plus models. Please like and subscribe to the channel. See you next time!